Gold remains one of the most valuable and sought-after precious metals in Earth's crust. To obtain just 6 grams of gold, it's necessary to extract and refine an entire ton of ore. But gold's story begins long before Earth even existed. It is a heavy element, which means it cannot be created through ordinary chemical reactions. Gold can only form during extremely violent cosmic events, such as supernova explosions, when massive stars collapse at the end of their life cycle. During these explosions, energy levels become so intense that lighter atomic nuclei fuse together, forming heavy elements like gold, silver, and platinum. Millions of microscopic particles are then scattered across space, eventually mixing with cosmic dust and rocks. In Earth's early history, the planet was a molten mass. Heavy elements like iron and gold sank toward the core due to gravity. However, a portion remained trapped in the crust and mantle, thanks to intense asteroid bombardments around 4 billion years ago. These asteroids carried gold and other precious metals, enriching the outer layers of the planet. About 2 billion years later, hot water trapped deep within the Earth began circulating through fractures in the rock. These hydrothermal fluids carried dissolved minerals, which, as they cooled, formed quartz veins. It was inside these veins that gold began to concentrate. Over millions of years, natural erosion broke down these formations, releasing gold particles into rivers and streams. But how is gold actually found, extracted, and refined? That's what we're going to explore. Gold is often found in rock veins alongside minerals like quartz and pyrite. Over time, certain regions of the world accumulated massive deposits. Today, the largest reserves are found in places like Australia, China, South Africa, Peru, and the western United States. Finding gold, however, is far from easy. Geologists start by analyzing detailed geological maps, searching for ancient formations and regions where the Earth's crust has undergone major transformations, ideal conditions for mineral deposits. Using satellites and aerial sensors, they detect chemical and magnetic anomalies in the ground, which may indicate the presence of gold. Next comes fieldwork. Soil and rock samples are collected and analyzed in laboratories. If gold is confirmed, exploratory drilling begins to determine the size and depth of the deposit. Then comes one of the most complex and expensive stages, extraction. When gold is close to the surface, mining is done through open-pit mining. Massive excavators and trucks remove layers of soil and rock, exposing the ore beneath. The land is carved into giant step-like structures called benches, allowing safe access for machinery. These mines can reach hundreds of meters deep and stretch for kilometers, forming enormous craters visible from space. In harder rock, deep holes are drilled and filled with controlled explosives, fragmenting the rock into manageable pieces. But when gold lies deep underground, the process changes completely. This is where underground mining begins. Tunnels are carved following the gold-bearing veins. Walls are reinforced with concrete and steel supports, while ventilation systems supply fresh air and remove heat and gases, which can exceed 50 degrees Celsius. Inside these tunnels, precise drilling is followed by carefully timed explosions that break the rock efficiently while minimizing structural damage. The extracted material is then transported to the surface for processing. At processing plants, the ore is crushed and ground into a fine powder. This step is crucial to release gold trapped within the rock. The material is mixed with water and chemicals, forming a slurry, where gold is separated using methods like flotation, gravity separation, or cyanidation, the most widely used method. In cyanidation, gold dissolves into a cyanide solution and is later recovered using zinc precipitation or activated carbon. The result is then melted in furnaces exceeding 1,000 degrees Celsius, producing molten gold that is poured into molds, forming bars known as bullion. However, even at this stage, gold still contains impurities. To achieve maximum purity, it undergoes electrolytic refining, reaching up to 99.99% purity. In this process, impure gold acts as an anode. When electricity passes through the solution, pure gold deposits onto the cathode as near-perfect crystals. Finally, the refined gold is melted again and cast into standardized bars used by banks, investors, and industries worldwide. From deep within the Earth's crust to gleaming bars of wealth, gold remains a symbol of power, beauty, and value, treasured by humanity for thousands of years. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications so you never miss new content. And if you want to keep exploring the hidden secrets of our planet, your journey is just beginning.